Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the file system structure in operating systems. File system structures. All the disk input output is performed in the units of one block, that is physical record size, which will exactly match the length of the desired logical record. Second point, logical records may even vary in length, but the packing a number of logical records into the physical blocks is the common solution to this problem. For example, the Unix operating system defines all the files to be simply a stream of bytes. Each byte is individually addressable by its offset from the beginning or the end of the file. Next one. In this case, the logical records are of 1 byte. The file system automatically packs and unpacks the bytes into physical disk blocks, say 512 bytes per block as necessary. The logical record size and the physical block size and packing technique determine how many logical records are in the each physical block. Last one, the packing can be done either by the user's application program or by the operating systems. Next, we have the access methods. In access method, first method is a sequential access. The simplest access method is a sequential access. Information in the file is processed in order, one record after the other. Second point, this mode of access is by far the most common. For example, editors and the compilers usually access the files in this fashion. Third one, the bulk of the operations on the file is reads and the write. Fourth one, the read operation reads the next portion of the file and automatically advances the file pointer which tracks the input of output locations. Similarly, a write appends to the end of the file and advances to the end of the newly written material, that is the new end of the file. Next one, such a file can be reset to the beginnings, and on some systems the program may be able to skip forward or backwards the end records. For some integer n, perhaps only for n is equal to 1. Next point, sequential access is based on the tape model of the file and works as well on the sequential access devices as it does on the random access ones. Next access method is direct access. Another method is the direct access, or it is relative access. A file is made up of fixed length logical records that allows the program to read and write the records rapidly in no particular order. The direct access method is based on the disk model of the file, since the disk allows the random access to any file block. For the direct access, the file is viewed as a numbered sequence of blocks or records. The direct access file allows the arbitrary blocks to be read or written. That we may read the block 14, then read the block 15, and then write the block on 7. There is no restriction on the order of reading or writing for the direct access file. Next one, direct access files are of a great use for the immediate access to the large amount of information. Databases often of this type. When the query concerning a particular subject arrives, we compute which block contains the answer and then read that block directly to the provide the desired information. The simplest example on the airline reservation system, we may store all the information about the particular flight. For example, flight 713 is blocked identified by their flight number. The flight number of seats for the flight 713 is stored in the block 713 of the reservation file. Next one is other access methods. Other access methods can be built on the top of a direct access method. These methods generally involve the construction of the index for the file. The index, like an index in the back of the book, contains the pointer to the various blocks in find a record in the file. We must search the index, then use the pointers to access the file directly and find the desired record. One solution is to create an index for the index file. The primary index file would contain the pointers to the secondary index types, which would point to the actual data items. Thank you.